Hey, welcome back to the Emergence Show. I'm incredibly excited for today's episode because this is our season finale, and we're going out with a massive conversation. We are bridging two worlds that rarely meet: high-end entertainment and hardcore science. My guest today has quite literally done it all. He was employee number 7 at LucasArts. He worked side by side with Steven Spielberg at DreamWorks, and he served as the chief game designer at Google. But he didn't stop at entertainment. He is now applying those skills to what he calls the biology of play, creating games that treat ADHD, help stroke victims recover, and even fix vision loss. Please welcome the legendary Noah Falstein. Noah, it is such an honor to have you here to close out the season.
And thanks so much for those kind words.
Of course. And for everyone tuning in, I know it's December 23rd, so thank you for being here. Drop a hi in the chat. Let us know where you're watching from. And get your questions ready because we're diving deep into the future of neurogaming. Awesome. Thank you again, Noah, for being here. I'm so excited. And thanks to David Fox, who is now in the chat as well and referred you to be on this show. So grateful for all of you. He was here for the Halloween and you're here for the Christmas. So great timing, great legendaries on the show. Noah, before we dive into the questions, I would love for you to tell us about your story, your journey. You have spent decades mastering the art of fun with legends. So I would love to hear from you, kind of how you stayed in the gaming space and expanded into many more industries.
Sure. Well, the simple explanation is I've always been really interested in new challenges and new things. And when I was in college, I discovered computer games at first. And when our college got our first video screen, because before that it was all paper printouts, I thought, wow, you could make a really interesting game using this video screen. And there had been a few video games in the arcades, but there were really very few home computers hooked up to, at that point, hooked up to our televisions. So it was just a matter of wanting to find the cutting edge. And it didn't occur to me that it was a career that I was moving into, but it certainly became that. And in general, what has driven me is that there's always been some new interesting thing on the horizon, and I love the way that the games industry is constantly reinventing itself. Things are so different now when so many people are playing on, high-end consoles, or more likely even the phones that they have in their pockets, which was just unthinkable when people like David and I were just getting started, 40 some years ago now.
Wow.
And so really what happened to me was I enjoy the creative challenge of trying to figure out how to make really fun, entertaining games. But it's kind of a master level challenge to make something that is fun and entertaining, but also serves a purpose beyond pure entertainment, like medical treatment or training or education. And that's really what's drawn me to this area that I'm in now that we'll be talking about, because it just means that I get to use everything I learned as an entertainment game designer, but also bring it into a new level of complexity and challenge to make it do something besides pure entertainment.
Love it. Thank you so much for sharing. Was there any specific aha moment that that made you realize that these same mechanics could be used, to treat diseases?
Yeah, there were several actually along the way. The first step was the late '90s when I was invited by someone who worked at Shell Oil to come out to the Netherlands to talk about using games to train people who had to go out on oil platforms. And it was the idea of a man, Piotr van Schothorst, who invited myself and several other game developers out there. And the idea that big companies like Shell Oil would be interested in games for some purpose beyond entertainment, that really planted the first seed. And just a few years later, and I'll talk a little bit more about this when I get into our deeper questions. I was working with a company called Hope Lab on a game called Remission to help kids who had cancer, leukemia for the most part, because these were teenagers, and helping them understand why they needed to stick with their chemotherapy regimens. And that was the first game I worked on that was purely for health, and also had a huge budget in the tens of millions of dollars to do a very large randomized controlled trial to show that it was actually effective. And it just proved to me and to a lot of people in the world that games could actually have a really significant effect on people's behavior in very important, medical ways.
Wow, really powerful. Yes, we're excited to hear more deeply. So if you want to share your screen, we can get that started. And again, for our amazing audience, if you have any questions, put it in the chat. We'll definitely get into it. It's really exciting conversation. Awesome. So let's talk about this idea of biology of game design. Let me share your screen here. Awesome. Yes, the emergence show. So you talked about the biology of game design. Can you explain to our audience, engineers, innovators, how play is actually nature's way of teaching survival skills, and how we can reverse engineer for product design?
Sure. Excuse me, I'm just getting over a mild cold here. I think it goes back for me to those early LucasArts days, and David Fox and I both were working with Steve Arnold, who was our boss for a chunk of time there. And Steve would ask us, what's the funativity quotient of this game? How fun is it going to be? And the idea of sort of measuring fun and thinking of it almost scientifically was exciting to me. In those early days as well, in the 80s, I was interested in how, what is fun? What does that mean to us as human beings? And my friend Raf Koster and I were talking about this, and he ended up writing a whole book on it that I can highly recommend, a theory of fun there. And about the same time, I think actually a little before his book came out, I had published something online that I called Natural Funativity. And that was, Steve's funativity question combined with natural selection. But the basic idea is that fun and play is not something that is just restricted to humans. It's not even restricted to mammals. There are reptiles and birds that show play behavior. But what it comes down to is many animals and all human beings, particularly early in their lives, play. And you'll see, we're used to cats and dogs, and when kittens and puppies are playing, they're practicing adult skills. The kittens are stalking and jumping on, maybe it's a ball of string, but you could see that they're working on their techniques to track and catch prey. Dogs are often involved in pack behavior and which one is dominant and how to work with the other dogs. And of course, as humans, we do the same kinds of things. We try out, play acting, being adults in various ways.
Very interesting. Yes, such a good observation. And that is something important we shouldn't forget. It's not just for the kids. Even adults can benefit from it. Awesome. And if you want to quickly just explain to us, how did you guys go about measuring fun? I'm really curious.
Well, I mean, certainly that's been one of the hardest things to quantify. I have friends who are more researchers who get into that. Maybe I can mention there have been a lot of scientists over the years that have looked at it in different ways. That this is a really interesting thing that very few people know about, and this picture is literally the only one I've ever been able to find anywhere of the experiment that was done, but there was a researcher, a psychologist, I believe, named Harry Harlow. He's known, a lot of people who've taken psychology classes will have heard about a cloth monkey experiment he did, but I won't get into that. Before he did even that, in the late 1940s, he was hired to see whether he could increase workers' productivity by paying them more, and whether you could actually get them to be more productive by increasing their fees. And he used these rhesus monkeys to test that out. So he was trying to quantify it as a question of how long would they keep doing their job. And their job in this case was, as you can see, some simple puzzles that were on the side of their cage. And he did it in good scientific fashion. He had a group of monkeys that were the test subjects and a group that were the control subjects. And he gave the same puzzles to both of them so they could get familiar with it. And to his surprise, both sets of monkeys actually started playing with these puzzles immediately. He didn't need to pay them to do it. But when the experiment started, after letting them get familiarized with it, he would give food rewards. I think it might have been grapes to the monkeys that did more and more work on these puzzles. And it worked quite as he expected, that they increased the amount of time they would spend working on the puzzles if you paid them. But he also found that he had to keep paying them more and more to keep them going. And meanwhile, the control group kept playing, but not as much as the ones who were paid. And then he stopped paying them. The test was over. He stopped paying the test group, and they immediately gave up and had no interest in those puzzles after that, after they stopped getting paid for it. But the
Wow.
funny thing was the control group, who he hadn't paid at all, kept on going and actually went much longer on the puzzles and got much better at the puzzles than the group that had actually been paid at all. And so it actually contradicted his hypothesis that paying workers was the best idea. He just found that the monkeys, he didn't call it fun and play, but it's hard to, I mean, you look at these little monkeys, and particularly that one jumping on top of another one, even to get closer to it. And it's amazing how similar to what human being behavior can be that way.
Wow. So does that mean like the internal motives and incentives are even more powerful than the external ones?
Yeah, and there you may have heard of something called self-determination theory by DC and I've forgotten the other guy's name, but they actually based a lot of their studies. That's how I first heard about Harlow's experiments. And
Mm.
they basically talk about intrinsic motivation, that we're actually much more likely to keep doing something if it feels important to us personally and we're not extrinsically motivated, which would be, for example, being paid or being ordered by somebody else who's our boss to do something we don't want to do. If it's something you really enjoy, something you want to do, then you do it more and you actually do it better over time.
Very interesting. That's makes sense when people say like there's no real burnout. Like you get burnout if you don't love what you do. So interesting. Thank you for sharing that. And curious, so is this something that can be used like this? Adding fun can be used in a way that we can turn boring medical repetitions into some sort of compelling gameplay loop and encourage the patients to be more active into the process, or like what are some of your thoughts on that side, like using game to improve the medical procedures?
Yeah, well, it's very nuanced and multifaceted. So I'll try and summarize. Let me just mention, sort of along these lines, that something that is unique to humans is storytelling, and
Mhm.
that is also a way of using intrinsic motivation to teach lessons. Entertainment in general, not just play and games, I think, are fundamental teaching methods that we've had, going back actually, obviously, to sort of pre-human times, but also early human times. And the idea is that tens of thousands of years ago, people, we don't know for sure that they were telling each other stories around campfires, but it seems awfully likely that they were sharing key information about, oh, this is what I did to fight off the saber-toothed tiger, or this is what I did when I was really starving and I found that there was a certain kind of plant that was actually edible if you dug up the roots. And the pictures in caves go back, 20, 30, 40,000 years, and were remarkably detailed. And again, we don't know exactly what their purpose was, but in many cases, they show pictures of animals, dangerous animals, animals people hunted for food. And it just makes sense that entertainment in general has been doing this for a long time. But just to get to your specific point, there's something called the flow channel that was first proposed by a different psychologist named Mihai Csikszentmihalyi. And this is something that's been adopted by game designers everywhere, in that you really need to gradually increase the difficulty of a game over time as people's skill increases at the game so that they can stay interested. And if it increases too quickly, the games become too difficult and frustrating because the game got too hard too soon. If it doesn't get difficult at all over time, it gets too easy and repetitive and people start to get bored. So to your point, we are looking for ways to keep games in this channel, and that green line, that wavy green line, shows that it's not exactly a straight line. You want it to get a little bit tougher, and there's a boss monster you're fighting, and now you've vanquished the boss monster, and the game may even get slightly easier for a while as you pick up loot and you equip your party or your character, and then you move on to the next challenge. So that's something we've learned to do in games, and yes, it can be applied to medical, to training, to pure education.
Or even daily life. I was just thinking for workouts, similar concepts are applicable. You don't want to go like too hard and hurt yourself, or you get bored if it's too easy, or at work when you're onboarding to a new job. So very interesting. This chart is actually applicable to a lot of different topics, but yes, especially in game design. Awesome. Thank you so much for sharing that. And I want to transition a little bit more about different work that you've done in this space of kind of like medical gaming. And you worked on the first ever game cleared by the FDA to be prescribed as a drug. I would love for you to tell us kind of like the story, how that came about, and what were some of the challenges that you all experienced?
Sure, happy to do that. Let me flip through a few of
And if you
these to
want
get
to
to
talk
that.
about other topics as well, we can do that.
Oh, I'll be zipping back and forth. Excuse
Sure.
the quick transitions, but I brought up a bunch of slides, and I'll just go back and forth. So, what I can get into, separately, is that I actually had done other medical games before this,
Mm-hmm.
and that meant that some friends of mine contacted me. There's a really interesting connection in that I spent that time at LucasArts, and quite a few ex-LucasArts people have ventured into the same area of games for health, games for education. And I don't know if there's something about the kind of people that George and Lucasfilm hired, or whether it was just coincidence. But roughly, let's see, 14, 15 years ago, some friends of mine contacted me and said, yeah, there's this Dr. Adam Ghazali, who's the head of brain imaging at UCSF in San Francisco. And he's doing some experiments and wanted to bring in some game developers. And they knew that I had been working on games for health since about the year 2000. So they suggested that I come in, and several of us game developers, notably including someone named Matt Omernick, who went on to become a co-founder, worked with Adam. And on the left side of the screen there, first of all, you see somebody with an EEG headset looking at a screen, and the screen in the lower left-hand corner, you can see it's basically just a very simple game of a car driving along a pathway. And Adam, Dr. Ghazali, wanted to have a game where you had to do two things at once. He was actually starting to look at how distracted drivers, particularly aging drivers, had trouble staying on the road and driving well, and also looking at signs that would go by, because you have to split your attention back and forth, and he's very interested in attention. So to keep a long story short, he made us, he had us work with him to make this game that ended up on the cover of the journal Nature. You can see there the only time Nature has had a video game on its cover. And he published a paper on it, did very careful controlled trial on this, and found, in fact, that using the game, he could help train people to be better at staying on the road, but also looking at signs. And that became the company known as Achille over some years later. I came in and out of the company. I'm still technically on their advisory staff, but the job to come to Google was too tempting for me to stick with them for those early years. But Matt and Adam and Eddie Martucci, the CEO, founded the company. And as you say, they went on to do, they raised first tens of millions of dollars, because it's extremely expensive to do these big tests. You need hundreds of people. You need to have one group getting a placebo and the other group getting the treatment. And they were able to show that this game, Endeavor RX, is about as effective in many ways as Adderall or Ritalin in treating ADHD. But the side effects, instead of some of the serious side effects you get from drugs, the top two worst effects that the FDA was able to measure were occasional headaches and frustration. And we found that actually a little amusing, because that's basically kind of true of almost any video game out there. So the FDA cleared it. It is so far the only pure video game to be cleared by the FDA, so that a doctor can literally prescribe the game. There are other games that are in the works to get clearances, and it gets easier once somebody's broken through that barrier. So those two screens on the right are images from the game. We had high quality team of game developers, high quality group of doctors and researchers, making sure we were doing everything right. And it's a formula that other companies are following now, that I expect to see quite a few follow in the coming years.
This is really fascinating. Is there like a dosage of game that they prescribe, or like how does this even work? Or do they just recommend like, hey, this game is good for you?
Well, all the companies I've worked with that are doing this establish dosages, and in order to get the kind of clearance you get from the FDA, then you do need to say this specifically with Endeavor RX. If I remember correctly, it's about 20 minutes, 25 minutes per day, 5 days a week for, I think, 5 or 6 weeks is a sort of standard dosage. And
Wow.
as with pharmaceuticals, drugs, there is some experimenting going on. The odd thing here is that, unlike a drug, when we were playing the game, we were testing it just as we test any game. And so people were playing it for hundreds of hours, not just a prescribed few. And nobody had any particular bad effects from that. I mean, it's rather interesting to look at the power of games that way. They're very different than pills in that it's much harder to take too much of a game and have an adverse reaction, whereas with pills, obviously, it can be quite dangerous. And it's still such an early field that I don't think there's any easy way to know exactly what the right dosage is. Another game I worked on that perhaps we'll talk about is trying to treat nearsightedness. And in that one, they only needed about 10 minutes a day, but they needed it for, they think, up to about 2 years every day, which is a long time to test. And the company ran into trouble just trying to get people to stick with something over that long period of time.
Wow. So is that like that dosage is kind of like the minimum required to see results, right?
Well, it depends a lot on what it is that you're treating. So with ADHD, it's a mental a condition. I don't want to say illness, because I think one of the interesting things that we found is that ADHD in the right intensity is kind of a superpower. And to get back to Darwin and evolution, it's pretty clear, to me at least, that things like ADHD and autism are in our gene pool because when you have the right amount of it, becomes extremely useful, not just to an individual human, but to entire tribes and groups. And a lot of scientists are diagnosed with both of those conditions. But when you have too much of it, the genes happen to come up that you have really acute case of autism. It can make it really difficult to function in the world. So training somebody how to deal with how to essentially control something like that is quite different than, for example, the nearsightedness thing, which was more of a physical change, or recovery from stroke, which is, or exercise, as you mentioned before. All of those are physical things that you really need to train your body in different ways. And the amount you do per day has a lot to do with, if you think about exercise, that you don't want to do it 18 hours a day, or you're going to burn out and probably injure yourself. Um, so there are optimum amounts, but it varies considerably depending on the circumstances.
Love it. Thank you. And we do have a couple of questions, but before that, as you brought up the VR project for nearsightedness, if you want to share any screen and expand a little bit more on that.
Sure. These are a couple of physical treatments that I mentioned. MindMaze was a company I worked with that they are a Swiss-based company treating people with strokes and helping them recover. There are many different ways to do this. Some people use VR. The MindMaze group mainly uses cameras hooked up to look at the patient who's recovering from a stroke, and then they see a screen, and they have to do repetitive motions that can be actually very difficult or even painful. And it was hard to get them to do it. It's particularly hard to get them to do it at home. But if you are controlling a game with those motions, it was interesting to see it flip from trying to get them to do it enough to actually having to cut them off after a certain amount of time, because some people were actually straining their muscles. They were enjoying the game so much. Just trying to get them do simple motions like the one you're seeing here is controlling a dolphin swimming after fish. On the right side there, you see the treatment for myopia I was mentioning, and it uses VR, but not in the way that a lot of people are probably expecting, that the 3D aspect of VR was basically immaterial. What they really needed to do was to be able to take over your whole visual screen. So you needed to put on the headset to screen everything out except what you were looking at. And they used some of the simplest and cheapest VR, where you take your smartphone and stick it into a headset that can cost as little as $30 or $40. And you can have a little Bluetooth game controller, also maybe $10 or $15. So for people who already have phones, which of course is a lot of people, it was a very cheap treatment. And in their case, what they were trying to do was recreate a certain frequency of blue light that happens to be exactly the color of a blue sky on a clear day. And there's a evolutionary reason to believe that subjecting a certain part of your eye to that blue light is what triggers us to have better distance vision. I don't want to get deep into the science behind it, but there are some really interesting evolution-based ways, in fact, that suggests that the reason there is a big increase in nearsightedness is because a lot of kids are growing up spending more time inside than they used to, and our bodies are triggered that if, for example, children who grew up in the Amazon jungle are often nearsighted because almost everything they see is close up. They can't see very far in a thick jungle, and they don't have a lot of blue sky, and we're evolved to focus our vision closer in if we're not in those sorts of circumstances.
Wow, such a good point. And I'm curious, did you guys capture any results or studies of how much improvement existed when people started using them, adopting them?
Oh, of course. In Dopavision, the company doing the nearsightedness treatment, has run into trouble because you need to raise pretty immense amounts of money to do those sorts of tests. Achille managed to raise, I think, about 70 or $80 million, and then went public and got even more than that, over 100 million going. They were an early unicorn with a $1 billion valuation. And Dopavision was only able to raise about 12 million euros, and that turned out not to be enough, even though it's a large amount of money. To develop a game is expensive, but to actually test it can cost 2 or 3 times as much as the cost of developing the game, which is typical for pharmaceutical companies. Are used to that. Developing a pill is generally cheaper than testing whether that pill is effective or not. But for the games industry, we're used to thinking of testing as a relatively small portion of your overall budget. And when you're doing these medical types of games, it can often become, even 70 or 80% of your budget just to do the testing.
Wow, interesting. Yeah, I mean, it's kind of sad because these are so effective and can be so impactful, but they're not widespread because, they're not invested heavily. Or like, what do you think are the challenges of adoption for this? Is it marketing? Is it the results? Is it funding or just general belief?
Oh, it's a lot of different things. Achille had a lot of trouble on the sales side because doctors are very used to prescribing pharmaceuticals, and there's a entire industry of people who go out to doctors to show them pills and give them free samples. This has shown up in a lot of movies and TV shows, and there was really no mechanism. There's still obviously no mechanism for doctors getting a chance to play these games. And certainly a lot of doctors had no interest in actually playing the games any more than they wanted to sort of sample all the pills themselves. So you really need to break through the sales and marketing side in something like that. For educational games that we'll talk about more in a minute, I think there are even more gatekeepers that if you want something to get into an actual classroom, you not only have to get the kids interested in playing the game, you have to make sure that their parents think that it's okay and that teachers don't turn away from it because it's one of those games that in the minds of most teachers, games are the enemy of what kids are doing when they're not learning. So saying that it's a game that will teach them something is difficult. And getting the teachers and parents and the kids all excited does nothing at all if you can't get the people who approve games for schools and the districts and principals and people along the way, much less than at the very beginning. You need to convince somebody to put in the tens, if not hundreds of millions of dollars to develop really high quality games that can be used for these things. So many, many ways along this path that you can be stopped by any number of problems.
Yeah, very interesting because gaming industry is so huge and people are playing games anyways. So why not playing games that are more impactful? And also on the kid side, like they are already in Roblox, Gen Alpha and all that. And so like why not moving them towards something more beneficial for them? Yes, we're going to get to the ed tech side, but let's answer a couple of questions
Sure.
from Felipe. He asked, from a developer perspective, how much medical accuracy do you have to sacrifice to make the gameplay actually fun? Is there always a trade-off?
Well, there's always a trade-off, but I don't think of it as sacrificing the medical accuracy. I mean, certainly one of the things that was really interesting for me in my journey here. Actually, let me take this moment to just zip through some of the early things. One of the early games I designed that was meant for both education and health was a childhood nutrition game called Hungry Red Planet. Um, the title I really wanted was Little Green Menu from Mars, but it was a game about allowing kids to pick a menu of foods that they wanted and to see how healthy it would be. And this was in the days where the food pyramid was a big deal. And I stole a little bit from Star Trek. You can see on the right side, there's a bunch of bar graphs. They're all green and yellow there, but that was based on the medical beds you see in Star Trek, where they're showing all the different types of indicators up on a screen over somebody. At any rate, the idea here was to teach children nutrition, and we were able to do a good job. We actually did some tests to see that they were learning a lot about nutrition, but then we informally asked them about how it had changed their eating habits, and it basically had zero impact on their eating habits. It just made me realize that it's really hard to change people's habits. It's one thing to change their minds about something, and literally with the ADHD treatment, it's actually easier to change people's brains and the way they're wired than it is to sometimes change their voluntary behavior about those sorts of things. So it's quite complicated, and I would just say that the most successful companies that I've worked with that I see out there, companies like Achille, something like Relevate Health Games, which is they used to be called Level X. Embodied Labs is another company that does training for caregivers. Those are all companies that do their very best to make the games as fun as possible and the medical treatment or training or effectiveness as good as possible, and to find the local maximum of those two things. So I don't look at it as sacrificing something so much as looking for the best balance and payoff where both the games are really fun and good games and not just a sort of gamification slap on a high score table, but also that the medical treatment or training that you're getting, in the case of Relevate Health, you can get continuing medical education credits just for playing their games, and this is something that big boards, that trained doctors have to certify. So you really need high quality in both of those areas.
Amazing. And did Achille produce any other games, or was it just that one that went viral?
Well, it's complicated. So they're still around. They ended up getting sold off to another company, and they're working on some new games. When I was working with them, we had several games in development, and they did release a what they call an over-the-counter version, just like over-the-counter medications that you have the ones that can only be prescribed by doctors, which was how Achilles started out. But when they found that they were constrained, they applied to the FDA for an over-the-counter license and got that, so you can now get the Achilles treatment without having to have a doctor prescribe it. But they are working on other games now. There's a company in Finland I'm working with that has a really interesting approach to a game on depression that I'm very hopeful about. There are many other companies that are working on wellness, which is a less rigorous thing where you don't need an FDA clearance, so you can get lots of treatments for anxiety or fear, PTSD that you get, and usually that's a mixture. Some are VR and some of them are not.
And I'm curious, is there like a marketplace or somewhere where we can find all these great games that are, health and wellness related?
Well, part of what has attracted me to this is that it reminds me of the entire games industry 40 some years ago, in that it's at its very early stages. And the answer is no, there is no really good single market, just as it took literally decades for things like Steam to come about from the start of the games industry. And I think it is still, a good 10 years out before there will be a good central clearinghouse for digital therapeutics or games for medical training, that sort of thing. But that's part of what I like about it, is that it's a little bit of a Wild West situation where anything can work, and there's nobody telling you that this is exactly how it has to be done. That was the way the whole games industry was 40 years ago, and it's become much more regimented. And I find it actually a lot more refreshing to be working in an area where there are no institutions or established ways of doing things, because it's more enjoyable for me. It's the way I get fun out of the work I do, to discover the best ways to distribute these or to get the public aware of it.
Beautiful. Yeah, I was just curious, and they have a comment saying that they're interested in the Achille game. So there is no way we can go and just download these games right now, or maybe
there are. I mean, actually, it's interesting, having worked at Google for years. Often the answer to these things is just go to Google or your favorite search or AI engine these days, and ask about, if you have a specific condition you're interested in,
Mm.
do a little research. Certainly, these are hard to find, not because the companies don't want to tell you about it, but because there's such a flood out there. But
Mhm.
certainly a good Google search, and increasingly, I think AI is getting better at doing this. Virtually every one of the half dozen or so clients I'm working with is working with AI, and each one is applying it in very different ways. AI in medicine is very tricky because hallucinations that might be actually entertaining in a game can be really dangerous if it's in a medical treatment. So that's a whole new area that I'm learning about, even as others are experimenting in it for the first time.
Interesting. Thank you for sharing. Speaking of AI, we have a question from Felipe. With AI moving so fast, do you see a future where the game engine adapts the difficulty in real time based on the patient's biometric data?
Yeah, well, there are a lot of ways where that's already happening. Actually, let me mention, exergaming has been something that's been around for decades now. A lot of people are going to remember Dance Dance Revolution, where it was not designed so much for exercise as fun, but a lot of people found that they were keeping fit and losing weight. I have a friend, Jenny Shu, who was inspired in part by Pokemon Go and has a new game out that's done quite well, that gets people out and walking and encourages them to do that. And I have the picture of Jenny up there because it really impresses me that, as well as running the studio and being the designer of this game, she runs marathons all the time. So, it's really a matter of committing yourself to that sort of thing. It's not just that she thinks exercise is a good thing. But specifically using AI, whoops, I guess I should go. Ah, I didn't mean to do that. I'm sorry. Um,
No worries. Okay.
uh, Going in the wrong direction here. This flow channel thing here, we are always interested in potentially games have been trying to adjust the game difficulty over time with very minimal biometric data involved. And when we had Achille, and you have that picture on the left with the starting with the EEG helmets there. A lot of companies are working with all the biometric data we have, but the Endeavor RX game actually uses not AI in the sense of a large language model AI, but more in the sense of AI as we have game developers have been using it for, since the 70s really, is that the game is constantly monitoring exactly how well the player is doing. And if they're doing a little bit too well, it makes it harder. And if they're starting to make too many mistakes, it makes it a little bit easier. And the flow channel for people with ADHD is actually higher than it is for neurotypical people, in that the first time I tested Endeavor in one of the early alpha tests, I said, yeah, this feels like it's way too hard. And they explained to me that they'd worked with the doctors, and the reason that a lot of people with ADHD um, will not get their homework done, or parents have a lot of trouble with that. But then they'll spend 3 hours on, Fortnite or Minecraft, and is because they need a higher level of engagement and a higher intensity in order to reach a kind of hyper focus, which can be extremely useful. And so that's what Endeavor does. Another company I worked with called Helium uses both consumer quality EEG monitors, but also watches or any of the wrist monitors that can track your heart rate. And they do relaxation games, and not even games so much as relaxation experiences that are tied into your biometric data, so that as you're starting to relax, it trains you to become even more relaxed, and tracks you in that journey, and gives you feedback showing how well you're succeeding in causing relaxation to happen.
Wow, fascinating. Thank you so much for sharing these tons of great games out there we didn't know, and we should definitely check it out. Awesome. We have another question, this time from Shadi. You've designed for pure entertainment um, and for serious health. Do you find that the definition of empathy changes when you are designing for a patient versus a gamer?
Boy, that's an interesting question. It certainly can. In fact, let me show you another picture. This is a picture of a boy who was a skateboarder and had an accident that stripped a lot of the skin off of his right arm. This is why it's all bandaged and under the covers there. And
Mm.
he was needing the bandages changed every day, and it was such a painful process that he would just scream and cry, and it was a terrible thing for him. And they were using opioids to calm him down, but for children, the limits on that are very strict, and they had gone up to the maximum dosage, and he was still finding it too painful. And then, luckily, Dr. Sam Rodriguez, who was at the Stanford Children's Hospital, had been experimenting with a VR distraction, basically. And it was a snowboarding down a hill. So it was perfect for somebody who was a skateboarder.
Mm.
And the very first time this kid had it, he went from needing the maximum dose of opioids to being able to actually have the bandages changed, which with no drugs at all. And he
Wow.
had very little response to it. And he was definitely one of the edge cases that was a perfect subject for this. But when you talk about empathy, Shadi, it reminded me of this because knowing that you can help somebody who's a 10-year-old in great pain simply through gameplay having a more powerful effect than opioids, just really gratifying to me to just see that this can happen in the world. And by the way, I was not involved at all in this, except that I was so impressed by what I heard about it that I helped Dr. Rodriguez get a few speaking engagements to spread the word about this sort of thing. But we're seeing games do amazing things. I mentioned in the teasers to this about games even saving lives, and the Hope Lab experiment that I referred to earlier had shown that they were improving the adherence of kids with leukemia to stick to their chemo treatments. And obviously they can't do a test where they see how many kids will die if they don't take their chemo, but by knowing that they were actually doing better at getting them to stick with these treatments, and that if they don't stick to those treatments, it really was risking their lives. That was my first experience to see that even with a big randomized control trial with I think over 300 patients, they were proving that there really was a significant chance that games could help not only improve but save the lives of people who needed that kind of encouragement.
Wow, really powerful. Thank you so much for sharing. And Tim Ryan put in the chat, could you please talk about Remission, a PC version? I believe you consulted with the Hope Lab briefly before I worked on it. Is that what you were referring to?
Yes, it was. That was an interesting case. I was, I think, involved in the third or fourth iteration of Remission, and the one that actually came out was number 7, if I believe. The couple that started eBay, the wife was the head of Hope Lab, and they had a personal wealth even back in 2000 of I think several $billion. So they were able to spend tens of millions developing the game, throwing out various versions until they got it just right. So I had a very small role in that. It's interesting to meet another person who's worked on that. They went through a lot of changes, but that just is part of the reason why this is so difficult, is that it can cost easily over $100 million to do a really good job at creating a new treatment, or certainly doing the tests to prove that something is effective that way. And I mean, the good news is, compared to in the early 80s when I was working at LucasArts, the idea of spending several million on a game was outrageous, much less 100 million. And these days, it's become a lot more commonplace. So we're seeing a lot of crossovers where the games are able to raise budgets that are commensurate with the kind of that you need for this sort of testing.
Thank you. That was very helpful. And we only have like 10 minutes left, but
Sure.
I want to definitely get into the EdTech conversation. And, I think there is a difference between gamification and game development. So I'm curious if you can expand a little bit more on that because we see a lot of developers are basically slapping a game skin on a boring quiz. So,
Yeah.
you know, why is it so difficult to make learning games that are actually fun? And how do you see the difference between gamification and game development?
Yeah, well, thanks for asking. I mean, I'm one of a fairly large group that is not fond of the term gamification. In fact, the most eloquent diatribe really against it was if you Google gamification and Ian Bogost. Ian's a friend who wrote an article for, I think it was Atlantic originally, and it's up on his website now. It's how you'll find it, but he talks about why gamification as a term suggests this kind of slap some easy thing on and it will get better. And there are a lot of people who like that term who are doing good work, but unfortunately, I've seen many more who use it as um, you know a placebo effect kind of thing of saying, oh, if it looks like a game, it'll be fun. And as Harry Harlow described, there are actually a lot of drawbacks to rewarding people in the ways that gamification does. And I've got this slide up of an old classroom that is probably from the early 1900s, but could be from the late 1800s. And frankly, except for the fact that we have whiteboards or maybe a screen in front, it's amazing how little classrooms have changed over the last 150 years or so. And one of the things that interests me is that there have been rare cases of games like Oregon Trail or Where in the World is Carmen Sandiego that actually got used by a lot of people. But they teach very narrow things. They're not part of what's called core curriculum. They're ancillary games that are on the side. And I'm really interested in, I mean, since games are, as we started, games are essentially learning machines, that play is all about learning. Marshall McLuhan, somebody who has a quote from him that says, "Anyone who makes a distinction between games and between entertainment and education doesn't know the first thing about either one." And when I first heard that, I thought it was an exaggeration, but I really think that good education and entertainment deserve to together. Um, but it has all of the problems that the medical world has, plus the difficulties of getting stuff into schools that I alluded to as well. And I've been working recently with the George Lucas Educational Foundation as a consultant, and I'm really excited because 40 years ago I was working with George, and he's really good at uh, trying technology in new areas like special effects in movies, or creating the group that became Pixar and creating movies with computers, or video editing. All of those things were things that he was trying in the 1980s, as well as promoting video games before a lot of people believed in them. And now he's been working quite a bit in education. The foundation was founded by George and Steve Arnold, the man whose picture you saw early in this talk. And it's really exciting to see that there are people who are trying to help bring education into the 21st century and find best practices for how to use games to do that.
Yeah, beautiful. Thank you so much for sharing that. Really impactful world. And yes, edutainment has become the new norm. Even we see it all over YouTube. So really important topic. Awesome. As we're approaching towards the end of the show, I want to answer one question and then we get into your predictions for the future. Shada asked, you have seen the industry evolve from arcades to VR. What is the one thing about game design that hasn't changed in 40 years, no matter the technology?
Well, happily, there are quite a few things that haven't changed in all that time. I would say the what I showed with the flow channel is one of the most fundamental principles that game designers learn. Some learn it explicitly through books about that. Some just pick it up by trial and error. But that balance of how to make a game progress and keep people engaged and at just the right level of difficulty, and have one game work for multiple people so that you can't have a single level of difficulty that's the same for everyone any more than you can have one shoe size that is going to have to work for everyone. So I would say that's probably been, one of the chief things I've found that's been important. But I will say just the pursuit of fun has been a constant all the way through, and what that actually means, our understanding of it has deepened, but our evolutionary wiring for fun has been this way for millions of years. So it's not going to change that quickly.
Amazing. Thank you. And we're seeing the early stages of brain-computer interfaces. I'm curious, what are your thoughts on that? Do you believe that eventually we will bypass the controller entirely and play games directly with our neural pathways?
Well, one of the things I've seen, 1984 was the first time I saw a game that reputed to be controlled by brainwaves. And in fact, it wasn't at that time. And that's been a goal people have been chasing for, 50 years at this point. And I do think that is eventually in our future. 10 or 15 years ago, I thought it was in our near future, and I've gradually realized we've got all this physical, biological hardware and software in our brains that is set to gain information from the outside world, and plugging directly into our brains in a matrix type way, I think is a lot farther in the future than many people are predicting. But giving us more sensory input. I'm a big believer, having tested Google Glass for about a year in 2013. I'm really excited about the new AR glasses and the potential for tying that to AI. I do think those are going to be extremely popular within the next few years, and will let us see that we don't actually need to get into our brains directly when there are so many other ways to use our eyes. The wristband that Meta has, I talked to those folks before they were acquired by Meta, picking up on our neural pathways through our skin without actually having to do invasive methods, I think is just going to continue to expand a lot faster than the really dangerous and messy stuff of plugging into somebody's brain directly.
Right. And we did talk about non-invasive BCI on another episode. So yes, this is definitely a very good direction. Awesome. Do you have any other predictions or thoughts about the industry beyond what we talked about?
Well, I'll mention to, I sort of preach about this quite a bit. The games industry, the core games industry, has had a really rough last couple of years with massive layoffs. And I have a lot of friends who are looking for work. And I've been trying to steer more and more of them to this area of games and health, games and training, which, as I say, is very much like the entire games industry was in the early 80s. And I think has similar potential for growth. That if games for medicine, for example, only expanded to be about 1 or 2% of the entire medical field, and I think that's actually a conservative estimate for how games are going to affect the medical field. That would make that little bit of the medical field about the same size as the entire game console market is right now. So there's $1 trillion a year spent worldwide on health in various forms. And there are so many ways that game-based processes, or people who have experience in games like VR, there are a lot of the VR people who are doing things that are not games at all for health, but are just treatments. They've come from the games industry because we're the ones who have done 90% of the work with VR recently. So at any rate, what it comes down to is I truly expect that we're going to see all sorts of wonderful improvements and expansion in the use of games for education, for training, for medical purposes.
Amazing, beautiful, impactful work. Thank you. And Noah, how can people support you, find you, and what's next for you?
Well, I'm really easy to find. I'm the only Noah Falstein in the world, as far as I know. So, plenty that's been written, plenty of talks that I've done. And, if you're interested in learning more, feel free to reach out. I am pretty busy, so I don't have time to talk to everyone, but I do the best I can.
Thank you so much for making time for this, especially on December 23rd. Thank you, everyone who stayed until the end with us. We're grateful for all of you. And this was the end of the Emergence Show for now. We will be back with a very different direction and topic in the new year. Thanks to all of you who engaged with us: Shada, Shadi, Tim, Christopher, Michael, Lee, Felipe, Ian, and everyone else. We will get to answer the questions we didn't get to afterwards. And Noah, if you want to share any links, please do that in the LinkedIn chat afterwards. Thank you, everyone. Have a wonderful holiday season. Take care. Bye.
Bye, everybody.